Good morning, guys. Again, let us continue with the next topic then. So, yesterday we were talking about something like operator overloading, and we already have seen operator overloading in Python is achieved by using method overriding. So, basically, when you are saying like you want to overload a operator, you have to literally go back and implement one of the methods there. I hope you might have got a chance to look at all these methods, and hopefully, you must have tried all of them. So, if you already have tried them, let's continue further and see the next functionality. I think Parag, your question is you said you have written a number object, but I've tried returning a string. It still works. Was returning a number object just a common practice? I hope you're talking about mathematical operators there in that context. If it is the mathematical operator you're talking about, where we were returning only the number object, the reason behind this is I hope you see, maybe I'll just go back here and create a page and then I'll just give you a simple example. So again, this is going to be page 1 as usual. So look at this example. Maybe if I have num is equals to 10, or maybe I'll say n1 is equals to 10 and n2 is equals to 20. When I say n1 plus n2, and if I store that result in, let's say, addition, what is the data type of addition? The data type of addition is always integer, because n1 is integer, n2 is integer. That simply means adding to integer will always give me an integer. So whenever you are looking at the mathematical operators, it behaves like this. You are adding two integers, you get an integer. You add two strings, you will get one string out of it. So that makes sense when you are having two numbers. So let's say this is a very simple class, again, like what I said earlier, a very simple class rather. And if I get a number here, then it makes total sense to see when we are adding two numbers, it should return a number. So let me just go back here and say num is equals to num, whatever it is. And probably in which case I can have that def or by def. It's underscore underscore add underscore underscore. Okay, def underscore 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 like this. And then when you are returning the addition, it makes total sense to return a number, because as per the standard practice, when we are talking about addition, adding two numbers or adding two integers, we get one integer. Adding two string, we get always a string. So adding two numbers should give me a number. So even if you return a string here, it doesn't matter. But when a caller is expecting addition of two numbers, then he is going to expect a number out of it, not a string or not anything other than a number. And that's the reason why it's a standard practice to return a number like this. Yeah, it is a number like this, and which you can get it by saying self dot underscore underscore number plus other dot underscore underscore number. That's it. So this is how we are doing it, and that's the reason why we have why we have written a code like this. Okay, so number 10, for example, n2 is equals to number 20, for example. And if I store, let's say, addition, in this case, I am guaranteed to get a number out of it. So if I just go back here and try to check the output, let's say addition is equals to addition and the type is equals to type of addition, then probably you will notice that it is not a number, it's not a string, it's not an integer, it's rather a number. So to do it, I'm going to say underscore underscore str and return here will return a string saying this is a number. I'll make it a little bit simpler. Maybe here I'll say this is self underscore underscore no. Okay, if you want, you can add some other things as well, like this is a number object and so on and so forth. Whatever you decide what you want to add, and as per your requirement you can do it. So when I say run, you see by default when I add two two numbers, number in a sense the number class objects, I'm getting a number out of it, and which makes total sense. So Parag, I think you got your answer. It's a standard practice that when you are adding two integers, you should get an integer. Adding two strings should get a two string. Similarly, adding two number class objects should give me again a number class object. That's the reason why we have done that. Again, it doesn't matter if you're not bothered about the type of it. Generally, this is the standard practice that we follow. Okay. So being said that, I hope you are comfortable with method overriding and operator overloading. Please look at the concept. The concept is method overriding and operator overloading. Overloading means using the same existing operator but giving them a new meaning to it. For example, plus by default will be used for adding two integers or two numbers, you can say. But now we are using that plus operator for adding two number objects, which is a kind of giving a new meaning to it. What what integer has done internally, what string has done internally, we have done that by using operator overloading. Again, there are many operators you can overload. You see, all the mathematical operators, comparison operators, you can easily overload them just by implementing the corresponding method. I hope you can understand that. It's very simple to understand and it's very simple to implement as well. String class overload, sub and divide method. Yeah, it's see, ultimately it is a str class, and whatever str class has done internally, it must be like you are not able to divide, or maybe you are not able to subtract two numbers there. So it's totally okay with it, because it depends on the class whether to implement this or not. So whether I should implement or whether I should support adding two class objects or not, it's totally dependent on me. I hope you are getting my point. So basically, when you are talking about something like this, you may understand this from the different point of view, that it's my class and I'll take a decision. Should I support addition of two numbers or not? Or should I support subtraction of two numbers or not? So it all depends on my class. So similarly, Python has taken this as a kind of leverage there, and Python has implemented all of this functionality in their own str classes, or maybe something like integer classes, or maybe something like float classes, and so on and so forth. Okay, so Deepak, yeah, it all depends on the str class whether to implement it or not. So you cannot just say that this is a hard and fast rule, but it is kind of a way to do it, a way to implement it. That's how it is. Okay. Okay. Another one question, Utpal. What is the advantage of operator overloading? I hope you can see the advantage here. Earlier, I was not able to add two numbers. Now I can do it. Earlier, I was not able to perform any, you can say, default operations like comparing two objects, or maybe adding two objects, multiplying two objects, or performing all mathematical operations on my object. It wasn't possible. But now with the help of operator overloading, we are able to do it. So probably, Utpal, to answer your question quickly, what we have discussed here, giving meaning to existing operators, is an advantage of operator overloading. Okay, so that's how it is. Okay, now being said that, let's continue further and take this OOP to the next level. So probably whenever we are talking about the OOP, whenever we're talking about the class, you always see that a class is nothing but a kind of collection of attributes and all the methods which are associated with those attributes. So this is what we already have seen earlier. Now we want to continue further, and we'll see how we can use this for the next example or the next concept. Forum, your question, def underscore str, is this condition always use an operator overloading? Forum, I think you are getting it wrong, unfortunately. Underscore underscore str underscore underscore, or dunder str, this is not operator overloading. This is an operator overloading. So maybe you can say this is overloading, sorry, overloading addition operation, or maybe plus operator, better. While this is not an operator overloading, this is rather, maybe you can say, string conversion. So whatever object you are creating here, you are just converting into a string, so that whenever you want to put that on console, it will be easy for you to display it without writing a separate method like print info. So that's the only intention behind overriding this str, dunder str method here. Okay, don't get confused between this and this. This is operator overloading. Next, maybe yesterday we already have seen like def underscore underscore gt, for example. This is operator overloading. So probably just quickly I'll say num is greater than others dot underscore underscore num. This is again overloading operator. So maybe I'll say overloading which operator? I think greater than operator. So that is fine. This is an operator overloading example. This is an operator overloading example, but this is not operator overloading. This is where we are just converting our object to a string. The only way, or the only reason why we do it is like when we want to put that on console, we can easily maybe easily get the maybe you can see the representation of that object, instead of just saying it's an object of blah blah class like this. If I put it, this is what the default implementation would be. This is an object of this class loaded at this memory location, which makes no sense to me at least. So when we are using something like dunder str implementation, at least you can see it's showing you the values in a way better format. And again, the control is in your hands. Okay. So hopefully you got the point here. Okay. So let us continue further, and let's go for the exception handling. So what is that exception handling, why it is required, and how we can take an advantage of the exception handling in order to stop my application from crashing. That is what we are going to see here. Okay, so let us see a quick example of it. So let's come back here and say this is going to be page 2. Okay, so probably what I'm thinking here is to write a simple function, very simple function. We already have done that earlier as well, if you can recall. I'll say this is n1 and n2, and probably I want to get the division of both this number. So let's come back here and say division is equals to n1 by n2. Whatever is the division, I'll simply go back here and say write this division and get the answer, correct answer precisely. Let's call this function divide and pass 10 2, and I hope we'll get an answer. Division equals to 5. That's correct because it's a very simple true division. I hope you remember that division is nothing but true division, and this is how it is. Now, what if I pass 10 and 0? I mean 10 and 0 in the sense the denominator here is 0. So probably when I say denominator is 0, which is invalid condition in mathematics because it will return something called as an infinity. So because it's not possible for us to divide any number by 0, that's what I hope my application is talking about. My application says, hey, you have got a 0 division error. In a sense, now your application has unexpectedly failed to run or unexpectedly crash because it has received a kind of an error from the mathematical operation, something like a division. So why it failed? It failed because you are trying to divide 10 by 0, which is not possible even mathematically as well. So if that is an error, how can we come out of that error? How can we stop my application from crashing? So this can be done by handling that exception or handling that error. In order to understand what exception handling is, first you need to understand what exactly an exception is. Now, exception is any runtime condition. Now, for example, when I started running this application or when I started developing this application, that was not work. I mean, that was not something I thought of. Maybe I just went with a simple division by saying n1 slash n2, and I tried to print the result there. It would work as well. You see, if I pass the second parameter as non-zero, so it would work. I can get my output here without having any problem. But at runtime, if I change that 2 to 0, probably my application crashes, which means there are few conditions or there are few events where your application is crashing. That is generally called as an error. Now, error in any language would be considered as of two types, or it fits into categories. One, there are few errors which can be controlled, and there are few errors which cannot be controlled. Those which can be controlled are generally called as exceptions, and those cannot be controlled are generally called as errors. For example, when I'm running my application and if there is no memory left to run the maybe next application, or there is no memory, or maybe the disk is corrupted, in that case, such scenarios or hardware failure, such scenarios we cannot control, because when they happen, we cannot do anything about it. If there is no memory, what can we do? Application has to go away, application has to crash. When the application is running and all of a sudden maybe the disk failed, when application is reading some data from a file or writing some data to a file, and all of a sudden the disk fails, what will happen? What can we do? Nothing. You can't do anything. The application will terminate at that point and will simply say can't continue because the disk on which it is about to write is not available. There are few conditions, there are few scenarios, there are few events which are out of our control. When we say those are out of our control, we generally call them errors. There are few though which are under our control and we can avoid them. For example, when you go for dividing something by 0, that can be certainly avoided. How can we avoid that? That's what we are talking about in this topic. So understand this. Exceptions are nothing but the runtime conditions there because of which your application generally crashes. In any language, there are two types of errors, so there are two types of exceptions, you can say. One is generally called as an exception, the one which can be handled. For example, 5 not found, divide by 0, the one which we are talking about, and there are n number of them. And another one is generally called as an error, which cannot be handled or which cannot be controlled. So those cannot be controlled. In that case, application anyways will crash. You cannot do anything there. But those which can be controlled, here we have to go ahead, accept those exceptions, do something about it, and we'll stop our application from crashing. So that's what we are going to do now. So how do we do this then? To do this, we'll have to go for something called as an exception handling. The name itself will tell you, you are going to handle an exception. So basically, when you say that my application is crashing because of an error, the error here is 0 division error. No, I don't want my application to crash. And if I don't want my application to crash, let us handle that error and gracefully come out of it, or gracefully let the user know that, hey, something has gone wrong, instead of letting the application crash altogether. So how do we do it then? To do it, first you need to identify which line can be a culprit. So probably if I think about the entire code, I think the line on which I may receive an exception or I may find an error is this. When I say this is the line, I'll consider this as erroneous line, or here maybe an exception can be generated. So I'll just mention here exception can be, or whatever, exception can be generated. So again, it all depends on runtime condition. You cannot just tell you, we cannot just assume it that it will crash every time or it will not crash at all. It may happen or it may not happen. That's the reason why we call them as exceptions. So it may or it may not. Everything was working fine in February, but all of a sudden the corona came. That was an exception. We never have thought of it. That was a runtime condition. If it wouldn't have happened, maybe everything would have gone straightforward. Everything would have gone very easily. Everything would have been so nice. But all of a sudden it happened. It was not controlled by us. It was not in our control as well. I mean, though it is in our control, but we are not still doing anything for it. Wish it could be in Python. We could have easily handled that by using try catch, the one we are going to do right now. But anyways, there are few scenarios and there are few events in your life as well where you will see them unexpectedly happening. You are thinking something else and something has happened. There also, in this line number 4, it may generate an exception or it may not generate an exception. If both the parameters are non-zero, or precisely if the N2 is non-zero, everything would go easily. There is no, or there will be no error. But all of a sudden, if I receive the second parameter as 0, there will be definitely an exception. So that's a runtime condition. That's a runtime error. So that's runtime error we are going to capture here. So that runtime exception can be captured by identifying the line on which you may receive an exception. So I already have identified it. Out of this program, line number 4 is where I may generate or I may get an exception. When you identify the line, the only thing which you have to do is you have to give it a try. Don't directly execute it. So I'm instructing Python, hey Python, don't execute this. Just try to execute it. So probably this is generally called as a try block. Let me just mention here and say this is the try block. A try block is the block which contain all the all the statements where the exception may be raised. We generally don't call a exception to be generated. I can say exception can be raised. So in Python, we use a terminology called as raising an exception. So here exception can be raised. When exception can be raised? When N2 is equals to 0. So whenever exception is generated or whenever exception is raised, don't let my application crash. Instead, tell me I will catch that exception here. Now, how do I, I'm sorry, sorry, my bad. I'm coming from the other one, sorry. It's except, not the catch. So I will try to catch that exception by saying, hey, this is where, just tell me that exception is about to crash. Don't let him crash. Give me a control and I will handle it for myself. So probably I'm going to go back here and say, hey, exception has generated or exception has raised. See here, exception has raised. Now, which exception has raised? I have no idea, but some exception has raised. Now, let us see what happens. I'm going to run this application again by passing non-zero. Let us see what happens. Look at the output now. When I say run, probably everything would go as expectedly. In a sense, division is 5.0. There is no problem because the N2 is non-zero. This is an expected output. And yes, everything is looking good. Now, if I call the same function by passing 0, you see last time application was crashing. This time, instead of letting the application crash, I received an exception and I accepted it that, oh, there is an exception there, fine. And I handled it gracefully by simply printing a message saying exception has raised. Look at the exit code. Exit code 0 means it's successful exit. Exit code other than 0 means erroneous exit. If you do not do this, probably your application would crash. And if your application would crash, you always will get the exit code is equals to 0. Exit code is non-zero. Most of the times it is 1, but it is non-zero. So probably when you're thinking about handling an exception, it's very simple. First, identify the block where you may raise an exception, and in that case put that block under try. So we are requesting Python, hey, just don't execute it. First, try to execute it. If everything goes well, continue further. But if there is some problem, if you find there is an exception, then instead of letting the application crash, let me handle it. I'm going to handle it inside another block called as an except block. So this is called as a try block, and this is called as an except block. In other languages, this is called as a catch block. So this is an except block. Except block is the block where you write the code in order to handle the exception. This is called as exception handling. Exception handling is a way you are kind of making your application aware that yes, there may be a situation in the runtime, but don't worry, I am here to handle it. So I'll try to execute it, and if nothing goes bad, everything will work smoothly. But something goes bad, I will handle it in this case. So this is something called as an exception handling. Very simple if you know what you are doing. So probably I don't want my application to crash. That is the only thing that I want to achieve here. As simple as this. So there are there are two things here. One, exception may be raised, or second, exception may not be raised. If exception may not be raised, or if everything is going smoothly, this try block will get executed. The division will be a valid value. You will print the division, and you will never go to that except block. But if you see there is an exception, then you will never execute line number 7. It will directly jump to the except block, and it will continue execution from here. So please remember, whenever there is a no exception, the program would flow in try block, and if there is an exception, then program will jump from the line where the exception has been raised to directly the except block, and from there the exception will continue. Okay, so that's the way we can do it. Okay, so probably things are kind of looking good, and hopefully you can take your own choice. So Prashant, whether should I swap it, or whether should I give an error, or what should I do? It all depends on your requirement. So what you want to do here, you decide whether you want to let the user know that you have passed a wrong value, or maybe you can let the user know that you cannot pass 0, or you should pass non-zero, or whatever, or you can swap the numbers and get the division, or whatever. It depends on you. So what you want to do is in your hands, but how you want to do is this. So we are looking at how to do this. What to do, you decide. Okay, so probably you can get the thing here, like this is the way to do it. I'll give you one more example, see if you can understand. I hope you can still recall, maybe we have seen a functionality to load or to read the data from file. Okay, so let's see this. Maybe I'm going to write a function 1, or maybe I'll say read file, better. Sorry, we are in Python. So read file, and then I can say the file is equals to, probably I'm going to say open, let's say /tmp, or maybe let's open this from the same directory. So do I have any file with the name myfile.txt? I don't think so. I'm going to read it anyways. So myfile.txt, and I want to read that file means of course the mode should be R means read. So let me just read the data completely by saying file.read. That is going to give me the entire data, and whatever data I'm going to read, I'll just put this on console, and probably I just want to verify whether the file is having a right data or not. Okay, don't forget to close the file. Once you are done, you should say file.close. Okay, let me just go here and call the read file function. Now probably what I'm going to do here is maybe I will create a file for now, myfile.txt, and we'll say that this is a test file. So at least we will have something to start with. I don't want my application to crash when I start it. So let me run this code, and everything is going smoothly. I'm able to read that file. I'm able to get the contents of that file. This is test file, and I'm able to see that on console. Everything went fine. Everything went fine because the file really exists on that path from where I was reading. So the file exists there. I could read the file. I could get the data out of it. I could print the data on console. Everything went smoothly. Now probably if I just change this file, or if I simply delete the file, instead of changing, let me delete this file. So if I delete this file, please delete anyways, and if I run my code, what will happen? So probably you would see that when Python will try to read that file from that given location, it won't find the file. it won't find the file, and that's the reason it will throw or it will raise an exception saying, hey, the file you are looking for is not available. So file not found error. The name itself is more than sufficient to understand what went wrong. So the file we tried to read here, the name is myfile.txt. It isn't there. I mean, it's not there in the location, and that's the reason my application is crashing. I see that. Error 2, no such file or directory present in this particular path. That's what Python is telling me. Oh, so now I see this is an error. Now, probably when you see that this is an error, naturally, I don't want my application to crash. If I don't want my application to crash, how do I solve the problem? Now, to solve the problem, I'm going to come back here and say, hey, try to handle this scenario. Try to execute this code. Don't let the application crash by directly executing it. Try to see if you can execute it. If you can execute, do what I said earlier. Like just go ahead, read the file, read the content, put them on console and go close the file. Good. But when you are not able to do it, then probably you should give me a control. Don't let the application crash. So give me the control in exit block and I will handle it. So instead of letting the application crash by returning an exit code non-zero, we will gracefully handle it. And we'll say that, hey, the file you are looking for is not found. So maybe I'll say the file does not exist. As simple as that, you know. So probably this is the way better solution instead of letting my application crash. You see, I'm not able to see any red lines here. I'm not able to see the exit code is 1. It's still exit code 0 means everything went successful. So whenever we are trying to read a file which does not exist, Python behind the scene will always raise an exception saying, hey, the file does not exist. And if that exception happens, I can handle it now without letting my application crash. I hope you are getting the concept. Are you? Guys, are you getting the concept? Okay, so at least couple of years, that simply means you are getting it. Okay, fine. So if you are getting it, well and good. Now I'll do one thing. I'll continue these two examples one more time, but in a little bit different fashion. Pay attention. This is going to tell you what do you mean by exception propagation and how to handle multiple exceptions by using multiple except blocks. Okay, so pay attention. I'm going to go back here. I'll create a same function in a separate file. That's the the divide function and read file function. Okay, so this is maybe the divide function. The one we have written. I'll pass n1 n2 again, and I'll get the division out of it by saying n1 divided by n2. Again, I'm blindly going for dividing n1 by n2. That's actually wrong, but it's okay. For now, I want my application to crash one more time so that I can tell you like why application crashes, how to handle it if not in the file and if not in the function, and what is the other way to do it. So probably I'm going to go back here and say division is equals to division, as simple as that. Let me call that function again by passing 10 and 5. Hopefully this is a valid example because I know the second parameter is non-zero. The division would work successfully. I would get the result and things will go smoothly. There is no problem. As usual, like last time, I'm going to go back and pass it 0, and I hope I see the application is crashing. The application is crashing because I saw that last time. It was kind of raising an exception. The exception was 0 division error, and that's the reason I was writing that under try. Okay. Now think about it for a second and see if I wanted to handle that exception here, I would have gone that and I would have written the code like this. See, so this is where we could say except, and we could say something like print, let's say error or exception raised, whatever, as simple as this. But I don't want that to happen. I mean, I don't want to write this code. Why I don't write this code? Because just for an example, I'm saying I am the developer and I don't want to handle this. Rather, whenever exception happens or whenever exception occurs, I want to let it pass to the caller. Now, probably I have written that function here. The function is raising an exception. I can accept that raised exception and handle it right here inside the function. But due to some reason, I've decided not to do it. So understand this. This is called as exception propagation. So whenever you, in a sense, the function is not handling the exception, one more time, when the function is not handling the exception in which the exception has been raised, it will pass it to its caller. I mean, it will pass that to the caller. Who's the caller? The caller is line number 6. Here we are calling it. So basically, you can go back here and you can say try and accept, or if you don't want to do it in the same function, then you can do it at the time of calling it. Because when I'm not handling an exception here, then the exception would get passed to its caller. To its caller, meaning here we are calling the function. Here I can go back and say, hey, try and accept. So probably you do anywhere you want to do, but you have to handle an exception in order to stop your application from crashing. So I will say again, exception raised, as simple as this. You know what happens in this case? So if I just if I see that it's working fine, I can see that it's not crashing and it's just telling me that exception raised. So I hope you can see when you are not handling that exception inside the function, it will get passed to its caller. That's line number 7. And because line number 7 itself is in try and accept block, in between the try block precisely, and it is having an accept block here, you can see the application is not crashing. See what happens in this context. If I don't do it, let me put this in comment for a minute and just call that function by passing 10 and 0. You know that because I'm not handling here, it will get passed to the line number 6. Because line number 6 is not in try, it will get passed to its caller. Its caller, in a sense, who is calling my function or who is running my code or who is running my application. Who's running it? It's nothing but the Python virtual machine. Absolutely right, Parag. It's PVM. So basically, when you are not handling it here, anyhow, either you are doing it here or you are doing it here. So if you are not handling it anywhere, this will by default go to the PVM. The moment it reaches to PVM, the default action PVM would take it, just crash the application. That's it. PVM doesn't care about your application. See, whenever it receives an exception, it says my default my default behavior is I'll let the application crash, or rather I will crash the application, so that the developer would understand that he has to add a try catch. So that's what the PVM generally do. I mean, that was the you can say the default behavior of PVM was. But now I want to override it. In a sense, I don't want my PVM to handle this exception for me. I don't want my application to crash. And that's where you have to write this try either here or here. So you decide where you want to do it, and this can be done like this. Okay, let me just give you one more quick example. See if you can understand that. And I need that answer from you. See, I'm going to write a function again. Let's say this is function 1. Within function 1, I can call that divide and say 10, 0. Now, can you tell me where in my code can I add the try catch? I mean, sorry, try except. Why I'm saying try catch? It's try except. Can you tell me where, what are the different possibilities that I can do here? Let me call that function now. Can you tell me where in the code I may add the try catch block? The first one is the divide itself. In a sense, whenever I know that I'm writing this division, this is the best option I should go for handling that exception. So I should say except, and there I can say print exception raised, you know. So that is the first thing. Fine, exception raised in the divide function. Okay, so if I run my code, everything will go smoothly. I mean, smoothly in a sense, the application will not crash, but of course, an exception has already been raised in the divide function. Good. Now, if I don't want to handle it, any other location, any other line number you can suggest me where I can add it? Yes, in the function 1 itself. So probably I know that if I'm not handling it here, this will get passed to the caller. Now, who's the caller of divide? Seems like function 1 is calling divide, means function 1 is the caller of divide. Okay, no big deal. I can do it here. See, I'm going to go back and say except, and we'll say that again the exception raised in function 1, or exception is handled in function 1. Whatever. You see, now I'm able to handle that exception in function 1. What if I don't want to do it here as well? Any other way, any other line number where you can suggest me to add the try catch? Of course, line number 16. In a sense, I still can do it here, and probably the exception can be again handled. So probably I can say write this and say exception raised outside function 1 or divide, as simple as that. So when I say run, you see now my application is still working. It's not crashing, it's raising an exception, but yeah, we are able to handle it right at this time. This is called as an exception propagation. The exception would generally get propagated to its caller. So if I'm calling that function 1 here, the function 1 is calling divide internally, and divide is where the exception is getting raised. You have three options to handle this exception. One, you can handle it right inside the divide function. Two, you can handle it inside the function 1 where we are giving a call to the divide, or you can handle it, this is the third and the last way you can handle it, inside your code where you are calling function 1. So that's how you can handle an exception, and this is called as an exception propagation. By default, exception would get propagated to its caller if you're not handling it where it should have handled. So I should have handled it here. If I'm not handling it here, then it will go to its caller. If I'm not handling it here, it will go to its caller. If I'm not handling here, it will go to PVM, and the moment it reaches to PVM, your application crashes. So remember this. I hope you got the point here. And if you have got the point here, let me continue further and give you one more scenario of doing similar things, but in a little bit different context. Pay attention. I'm going to get the same example one more time. That's a division example. I mean, I love that division example. So I'm going to do it like this. So I'm not going to handle it here. Okay, let's see what happens here now. Probably I want to go back and get the other code as well, where we were reading the file like this. And let me bring it here in my next example. So I don't need this one. I don't need this one. I would simply need a reading file code. I know that my file does not exist, meaning if I call that function, the function is going to crash. Okay, watch what happens. Now, for example, I'm going to call a function, let's say divide 10 0 or divide 10 2, and let's say read file. Now, I hope you understand, if I pass the divide 10 2, that simply means that the application would work normally, because this is not an exception or this is not an error. Or maybe this is not a situation where the exception can be raised, because it's very simple. It's 2 is non-zero, everything will work smoothly. There will be no exception raised. But you see that not because of the division, but because of the read file, my application crashed because the file does not exist. Now, what I want to do here is, like, I want to handle both the exceptions. In a sense, even if it is coming from divide or even if it is coming from read file, I need to handle them here. So how do I handle them? Simple. You just go back here, say try, and say this is except, and probably you can come back and say, hey, exception raised. Watch what I'm trying to show you. This is a little bit different than what I said, what I mentioned earlier, but hopefully you will understand that. Watch what happens now. When I run my code, okay, I see an exception being raised. I'm a little bit clueless because of what the exception has been raised, but I guess it's because of divide function, because I'm passing it as a 0. So let me pass it non-zero 5, and let me see what happens. Again, I see an exception raised, and again I'm a little bit clueless because I don't know what is happening. The exception is being raised, I understand, but which exception is being raised? Okay, in this case, it seems like the exception is being raised because of that file. I mean, the file not found. Okay, so probably I can just mention here is file not found exception is raised. Okay, fine. So now it is crystal clear that, yeah, this is a kind of file not found exception. But see the problem. What if I pass it 0? So when I say, if I pass that as a 0, oh, is it right? It says divide is now throwing an exception. Divide is now raising an exception. But it seems like it is telling me that file not found exception raised, which is actually wrong, isn't it? The exception is not because of the file not found. The exception is because of divide function is giving me a kind of indication that the second parameter is 0, and it is not the file not found exception. It is a kind of the divide by 0 exception. Okay, 0 division error. That's what you're talking about. So how would I recognize whether it is due to the divide by 0 or due to the file not found exception? If I do not handle it, I would easily see that. I mean, if I just go back here and say run, probably you can see that here and say, oh, it's because of a zero division error and not because of the file not found exception. So now I want to give it a try and see whether I can handle the scenario in a better form. Watch what happens and how to handle the scenario. To be precise, I have two statements to say. One is file not found exception, and the second one is like zero division error or zero division exception raised. So this is what I want to kind of differentiate between. So it can be because of zero division exception, or it can be because of file not found exception. How do I differentiate that? To differentiate it, write down one more except block. So this is one except block and this is this is the second except block. I want this exception block or except block to be dedicated for handling zero division error. In which case you can say, hey, this block, the except block, don't call it in any other scenario. Just call it only when the exception raised is equals to zero division error. So whenever you raise an exception, and if it is zero division exception or zero division error, just tell me here so that I can handle it gracefully. Or I want to go back and say, I want to dedicate this one for file not found exception. So file not error, file not found error, not exception, file not found error. So basically what we are doing here is, last time I was writing a generic except block. So probably I may add one more generic except block for all others that I have never imagined. So probably I can come back here and say, maybe a generic exception happened. So exception raised. Maybe I can say a generic exception raised. So probably when I say run, now it is crystal clear. Oh, it's because of the zero division exception, meaning it's because of the divide. I can come back, fix it, run that code. Oh, now look at this. I got the division answer, and yeah, now it is crystal clear that the exception is not because of the division. The exception is because of file not found exception. I hope you can see this. This again is a try block. Let me mention that here. Try block. Sorry, try block. What the hell? Try block. This one is an except block for handling the division error, divide by zero exception. So probably I can say handles the exception or error raised in divide function. This handles, maybe let me just go back here and say device or maybe handles the exception raised in what is that, read file function. And if other than two, if something goes back, something, I don't know, whatever it is, I can just come back here and say handles all other exceptions. Other than these two, everything can be handled inside this block. The one which is kind of having an exception attached to it, the except zero division error, is called as a specific except block. Again, this is just a concept. A specific except block is going to handle a specific exception. It's not going to handle anything other than zero division error. This is also specific exception block, which is going to handle only file not found error. That's it. Other than that, it will never handle anything. But this can handle anything, and that's the reason why it is generally called as a generic except block. Remember, you can have as many except blocks as you want, in which case you can go for a specific condition. Oh, this is zero division, this is file not found, this is ABC, this is PQR, this is XYZ, and so on and so forth. So it all depends on your requirement, whether you want to handle them specifically or maybe you want to handle them as a generic except block. So you can go for a generic except block on a safer side. So if you are not able to catch those exceptions right here, you definitely can handle them inside the except block. That's how it goes. Always remember, when you are having a generic except block, it's good to have a generic except block like this, but when you are having it, again, it's not mandatory, it's optional, but when you are having it, it has to be towards the end of it, or it has to be the last exception block attached to that try. See, I have attached the three except blocks. One to handle the zero divide error or zero division error, second to handle the file not found exception, and the third one is to handle any generic exception. It's like catch all. Absolutely. Vipin, it's not like actually catch all. It's like catch all except zero division and file not found, because zero division will be handled here, file not found will be handled here, and other than these two will be handled inside the generic except block. I guess you are getting it. It's like you are handling a specific exception in those two blocks, and here you can handle anything other than that. Whatever happens, you are not going to let your application to crash. That's the way you can do the job. So probably you now know one try can have multiple except blocks associated with it. Again, one except block can be a specific, or maybe other one can be a generic. Having generic exception block is a good sign of writing your code, so that if something goes bad, you can easily handle it. It's not only the file not found exception. Probably when you are reading the file and something goes bad and you're not able to read that file because of some bad sector in that disk somewhere, in that block somewhere. So probably your application is going to crash again saying, hey, file IO error. And if there is a file IO error, which you are not handling it here, you can easily handle that right here. So this is the way you can do it. What you see here, zero division error and the file not found error, all of them are inbuilt exceptions, inbuilt errors. Those errors, those exceptions, which Python has already given to you, and you are just handling them. It's not like you are defining them. It's like only you are using them. I hope you can understand that. So I think you must have got an idea now, like how we can get, how we can try a block and how we can handle an exception. Remember, exception can be handled with multiple except blocks. The only difference here is few except block can be a specific and one except block. I'm making my statement very clear. You can have few except blocks to handle a specific condition, but you can have only one except block to handle generic exceptions. So this is a generic exception block. You can have only one, and that has to be the last one in the list. You can have as many as you want the specific except block to handle specific exceptions, but you can have only one generic except block, and again it has to be the last one. So this is the way you can do it. I hope it's pretty simple to understand. Here zero division error is a class, or can we check that it's type? Just give me a minute, I'll talk about this. Okay, just hold your question, Pranit. You are going to get an answer in a very next concept, in the very next program. Nikhil, are we supposed to write an exception for each method? Not for each method, depending again what type of code you are writing. If I'm writing a code which, let's give it a shot one more time. Let's say this is another function, say add, and I'm just saying that n1 and n2. And here I'm going for getting an addition of both of them. Let's say n1 and n2. And probably if I just go back and say, hey, the addition is equals to addition. Now, probably when you're calling this function, I know this will never raise an exception, because we are not doing anything which is kind of dependent on runtime condition. Here, yes, we may see an exception because of the second parameter is wrong. So this is a code which is prone to error, but this is the code where we cannot, or where we don't need to assume that it will generate an error, because we are not doing anything like it. So being a developer, it's my duty to guess or to judge the code I'm writing, whether it may raise an exception or not. So probably, was that? So probably Nikhil, it all depends on the developer, and developer knows very well that, okay, when I'm saying division, it might crash because of the runtime condition. When I'm saying the add, it will never crash because I know there is nothing I'm doing which will raise an exception. When I'm reading a file, when I'm writing a file, it may raise an exception, and in which case it's always important for me to handle it. So it depends on the developer. I guess Nikhil, you got the point. Lomash, your question, can we give a name to an except block? No, you can't. I mean, it's not a name actually. It's like you are just going back and say except whatever is the exception block, whatever is the exception you are handling, and that's it. Nothing other than that. Okay. Kaushik, your question, when divisor is 0 and the file isn't there, it gives only an exception for divisor. Why doesn't it give for both? Very good question. But I think, Kaushik, you must have already imagined that whenever you are not handling an exception here in the divide function, it will come back here on line number 20. And the moment it finds an exception here, it directly goes from here to a particular exception block, and it will never come back here. It will continue executing your next piece of lines. Okay, so it will never come into read file. So in this case, if one of them fails, the other one will never get a chance to execute. For example, if divide fails, you never will see the add read file function is getting called. How do you handle it then? So probably the simple way is just put them in a separate try branch. So this can be also done. Again, if you are doing it, then probably I can say this is the good way to do it. So it again depends on how you want to handle the thing. So if you want them to be handled separately, you have to write a separate try catch. Now see, even if my divide is failing, let's make that divide failing. So even if my divide is failing, you see it's going back to the read file code. So basically, whether you want the next statement to be executed or not, you have to decide it, and accordingly you have to handle the exceptions. Okay. Okay, Sachinand, your question, is there any way we can get the error code? This is the way, in fact, we are doing it. That's it. There is one more way. Let's see this. But first, let's complete this one. Okay. Utpal, your question, is it possible to show the total number of exceptions in my code? No. How can you, in fact? Total number of exceptions, in a sense, you have to keep on counting them. Actually, when you are trying to get an exception, if you want, you can create a dictionary and say, hey, I got this exception at these many times. You can do it on your own. There is no way you can directly get it from inbuilt function, or precisely there is no inbuilt function that will tell you like how many exceptions has been caught or how many exception has been raised. Okay, it's your duty if you really want to do it. Anyways, so now we know like how to handle the exceptions, how to handle the built-in exceptions. Let us continue further and let us do it something different than what we have done so far. Till now, we have handled only the system exceptions, but it may happen that when I'm writing my code, probably I also want to raise exceptions manually. I'll show you an example. What do you mean by that? So hopefully you can understand that. What I want to do here is I want to go back here and say I want to get input from user. So probably I'll say print, and I'm asking user to enter a name. So here user will enter a name. Fine. So enter name means I'm going to get the user's name inside that function input. Getting that from input function. Next, I'm going to go back and ask user to enter, let's say, age. So whatever user enters, excuse me, I'm going to pass it right here, and then I'll print the name entered by user and let's say age entered by user, just for an example again. Okay, so let us come back, let us run this code, and probably it's asking me to enter name. I'll say user 1, for example, and what is an age? Age is 10. So whatever we have entered, that looks okay, that looks perfectly fine. Now if I come back and try to run this code one more time, the name is user 1, and if I enter age, which is kind of -10, you know that it's not a valid age. -10, what do you mean by that? I mean, you can't get anything out of it. So age cannot be in negative. So probably this is an invalid age. So probably when I'm getting an input from user, and if I'm saying that the age entered by user is not valid, in that case, I want to raise an error. Think about this. Maybe I'm handling that in a file. Maybe I'm handling that in a function, and that function is somewhere here. Let's say get input, get user input, or get user info, whatever. So I want my caller to know that if something is going good or something is going bad. If everything goes good, I will not do anything. But if the entered age is not a valid age, I want to raise an exception, so that my caller needs to know that handling age or getting a proper age value is important. So how do I do this? To do this, first of all, we need to find out whether there is any invalid age exception available with Python. Of course, Python would not have it. So probably if I just go and try to get it here, invalid age exception, no, there is nothing here. Okay. If there is nothing here, then we'll have to create our own. So how do I create our own? So probably I'm going to create a class named whatever you want to name there. I'm going to say invalid age error. And this will be an empty class. You don't have to do anything for that. Just create an empty class. If you want this class to be treated as an exception, One more time, if you want this class to be treated as an exception, or if you want to raise this exception, then there's only one thing that you have to do. You have to make this class derived from an exception. I hope you can read line number 1 and you can say that invalid age error is a derived class of exception. So this is the requirement. The exception class, or this is generally called as a custom exception class. A custom exception class, this is the mandatory part, must be a derived class, is a derived class of exception. Exception is something given by Python, and we are saying like whenever I find the age is not valid, I want to raise this exception. This is the first time we are defining our own or custom exception. At the same time, we are raising an exception ourselves. Till now, whatever exceptions were raised, all of them were raised by Python internally. I mean, they were raised by Python's built-in functions. But this is the first time we are doing it ourselves. So probably what I'm going to do here is, I'm going to first convert this into an integer age value. So precisely, you know that whenever you are getting input, it always will be in string. You know this. So what I'm going to do here is, I'm going to come back here. I'll pass that age to this. And here I'll say, convert the string to integer, as simple as this, so that it will be easy for me to check the correctness. So probably I'll say that if age is less than 0, maybe I can do this way. And if age for me, it's like less than 0 and greater than 100. 100 is too much. I mean, we don't leave that we don't leave that age these days, you know. 100 is too much. But still, if the age is above 100 or age is below 0, this is an invalid age. So for me, I'm going to say that raise an exception of invalid age error. That's it. What am I saying here is like raise a new exception. Raise an exception saying this age is invalid. So whoever is calling it has to now handle this exception. See what happens. And now you will see that how dynamic it is. I mean, how we are kind of getting it in runtime. Enter name. If user 1 is entering the age, user enters the age is 30, everything goes smoothly. There is no problem. But now I'm asking user 2 to enter the data. So user 2 enters username, and maybe by mistake or by deliberately, he enters it as -30. Oh, it seems like -30 is coming. Oh, what the hell? It should have coming. I mean, okay, let's see why it is going wrong. Is it less? How can it be? I'm so stupid. You cannot be having a number less than 0 and number greater than 0, right? My bad. It happens, you know. Okay, let's come back here and say user 1 enters the valid data, goes everything well, there is no problem. Now user 2 enters the data, and if I say -30, probably, see what happens now. Probably when I say run, my application crashes. Why it crashes? Oh, it crashes because look what it says. It crashes because of invalid age error. Look at that. Till last time, whenever my application was crashing, it was crashing due to the exceptions being raised by Python. This is the first time when we have raised an exception in case of age having invalid value. So if age is invalid, if age is not having a good number or the valid value, then we want to raise an exception, and this is the way to do it. Doesn't matter whether it's an invalid age error, invalid salary error, invalid name error, whatever it is. The concept is exactly similar. You would still create a couple of classes as per your requirement, and whenever you need them, you just try to raise them. This code is written by Python internally whenever it finds that the second digit is 0. So probably instead of saying a raise invalid error, Python internally is saying raise 0 division error, as simple as this. So probably what I'm saying here is what Python has done internally is what I can also do it here by defining my own exception, generally called as a custom exception, and I can raise it by using a keyword called as a raise. Guys, are you getting it? This is the third keyword we are using right now. I've used one keyword called as try, the other keyword called as except, and this is the third keyword we are using called as raise. Try to create a try block, except to create an except block, and raise to raise an exception in case of an error. Very simple. Now my application is crashing right now, just crashing because of invalid age exception. So if I add -30, you see it's crashing because of that invalid age exception. Oh, how do I handle it? You know that exactly like this. So this is try. I'm sorry. This is try. Maybe I can come back here and I can say, hey, this is an except, and I'll say that salary. I'm sorry, not salary. It's age exception. Exception raised. You know how simple is that? Let's do it one more time. Let's ask and let's ask user to enter value for a salary. So probably I'll say print enter salary. So user is now going to enter a salary. To get a salary, I'll go back here and say salary is equals to input, and that's it. We got a salary here, and probably I'll put that salary here as well. And let's see if user enters the right salary or not. I mean, if user doesn't enter right salary, for me, right salary is like maybe I'm working in a small scale company and my budget is, let's say, less than 10,000 per month, for example. So if it is the case, I'm just going to go back here and first convert the salary into integer. So convert string to integer by saying salary is equals to integer salary. And if it is the case, probably I'm going to check if the salary is greater than 5,000 or 10,000, let's say, that's what I said. Then I would say raise an exception. Now, which exception should I raise? I can't just go here and say invalid age exception. I cannot just go for zero division exception. I cannot go for file not found exception. For salary, I think it's better we can create one more class or one more custom exception. So probably I'll say invalid salary error. It is again a convention, not a compulsion, to have that class name ending with error. So we use a suffix called as error here, and it is just a convention, not a compulsion. Please remember, this class most derive from exception. So this is another class which we are going to use for saying that salary is invalid. So raise invalid salary. Invalid salary error. That's it. This is the way we can do it. Now, let's go back here, enter the data, see what happens here. Enter value, let's say age is 30, salary is, let's say 5,000. It's okay, everything will work smoothly. Let us run run our code one more time. Enter username user2, -30 is the value or 39 is the age, and oh, my application saying that age is invalid, just cannot continue because of the invalid age. Fine. Let me continue this one more time and see what happens. Now this time I'm going to say user4 or whatever it is. Age is valid, but the salary, let's say 30,000, which is not fitting in my criteria. And because of that, I want my application to say invalid salary exception raised, but oh, it says age exception raised. Can you just look at this code and tell me what is the fix? How do I fix this problem? Look at line number 37, 38, 39, 40, 41. Can you suggest me something to fix this problem? Meaning, if invalid salary exception raised, you should get that error for salary. And when invalid age exception or invalid age error raised, then you should get the error accordingly. How do I do that? Exactly, we should go for a separate except block. Absolutely right. So you got the concept here now. So basically, I'm going to now go back and make it specific. Earlier it was generic. Now I'm going to make it specific. For invalid age error, for invalid salary, I'm going to go back here and say this is invalid salary error. And maybe if something is going bad because of some other thing, I'm going to handle it right here. Maybe I'll say generic exception raised. Okay, so now I think we can capture all of these scenarios like user 1, -10, -3, whatever it is. You see age exception raised, which is absolutely right. You say user 2, age is valid, but salary is invalid. Let's say 60,000, and you see salary exception raised. This is the use case when you have or when you want to have something like a specific exception block. And in case if you really need it, you can go for an exception block. So this is the way we can do it. I hope you can understand. I hope most of you already have understood this. It's way simple to understand this. Okay, the only thing which is a little bit different here is like how and when you want to raise your exception. So here I'm raising an exception for salary, and here I'm raising an exception for invalid age. So this is the way to handle the exceptions in Python. Let's look at the one more example. Rather, I want to show you two more examples. This is the second last, and then we'll go to the last one in a minute. This is page 6. Watch what I'm trying to show you. Now, if there are 1,000 field, I can go for creating 1,000 classes for exception. Is there any better way? No, there is no better way. That's the only way you should go for. Okay. There are 1,000 cases. You should go for 1,000 exceptions there. This is the way you should go for, and this is the right way to go for. I mean, there are n number of ways to do it. You can create your own generic exception, and then you can handle it by using a method, but it's always better to create separate exception class to handle a separate situation. Okay, and it's not only in Python, it's always in other languages as well. It's always a good idea to have your own custom class so that you can handle the things separately for that particular scenario. So this is the way you should go for. Okay, now I'm going to show you one more example. See if you can understand that. So probably what I'm saying here is sometimes it happens. So maybe I can come back here and say this is a very simple scenario. Let's go back again, say division, or should I go for it? It's better, we should. So maybe I can go for that same function again. I love that functions, hopefully. That's the reason I'm going to copy it again and again. Okay, so now what I'm going to say here is, I'll call that function divide, pass 10 and 0. You know that it's going to crash my application because I have not handled it. Now, if I want to come back here and say, hey, I want to handle it in this way, say, should I, let's say this is the print function, and the print function is saying, this is the statement after my divide function is going to get executed. So next line after divide. Hopefully, if everything goes well, you see the next line after divide will get called. In a sense, it will execute the code sequentially. But as we already have said last time, it's always a good idea to put that divide in a except block, because I may get an exception because of the division. So this is an except block, and here I will say, by the way, this is a zero division exception, for example, and I will say that maybe n2 is 0, as simple as that. For a generic exception, I'll say simply an exception raised. That's it. Exception raised, whatever, maybe a generic exception has been raised. So probably when I say run, it seems like the division of 5.0, that's a valid scenario, and I see the next line after divide. Things are looking good, you know. Now, probably I can come back here and change this to 0, and you know that the next line will never get called. I mean, this particular line you will never see on the console, because you already have gotten an exception. You already have seen an exception here, and that exception has been already accepted, or maybe you can say already handled by this particular except block. So everything went well. But now what if I want to execute this line in any condition? So probably I may say that this is an exception or this is not an exception, but I want to handle it in any ways. How do I do that? The better way to do it is something called as the finally block. So every try can have 3 blocks associated with it. One is called as an except block, the other one is called as a finally block, and there's one more block called as an else block. I'll show you that example in a second. But see, this is a finally block. So I'm going to say, instead of next line, I'm going to say this is a finally block, and watch what happens. I'm going to say that this is a divide, this is divide 2 or 3, whatever it is. If I say run, you see that I got a valid division, and it says that this is the finally block. In a sense, right after executing this particular line, it has gone to execute line number 13. I'll do one thing. I'll just put that line as it is, like what I was having. Next line after divide, you know. So I'll keep that line as it is. And this is the code that I want to execute in any condition, in any scenario. So probably the thing is, I got that division valid error. I see the next line getting executed, and then it directly jumped to finally block, and yes, you see the finally block has been called. So it's for sure now the finally block called when there is no exception. We already have seen that. Last time I didn't get any exception, but still my finally block got caught. Very good. Now let us pass that divide is 0 second parameter, and you see that, oh, I got an exception. The exception is the second parameter is 0. You see, next line is not coming. Next line in the sense, this line is not coming, means this code is not getting executed. Whenever it finds an exception here, it directly jumps from here to here. But did you see something? This is finally block is coming here. Means now it's proved that it is called when there is an exception. So when there is no exception, finally block is called. When there is an exception, still finally block is called. Meaning finally block will get called all the time, irrespective of whether you are having an exception or not. So probably you can use it for closing a file, or maybe closing a connection you must have opened in for maybe consuming some services and whatnot. There are n number of scenarios where you want to execute few lines of code irrespective whether there is an exception or not, in which case you can put that code inside the finally block. So let me put it generic statement and say calls irrespective of any exception. So if an exception occurs, still this block is getting it's supposed to get called, and if there is no exception, still this block is supposed to get called. So irrespective of exception, finally block will always get called. I hope you are getting it, and if you are getting it, again please remember, you cannot have a finally block before except block. This is not possible. The actual sequence should be try, except, and finally. So finally must be your last block. You cannot have more than one finally. There should be only one finally block, and if you want to add a finally block, then it has to be the last block in try, except condition. So there should be try, then there should be except, and then there should be finally. This is how it should be. What are you saying, Shripati? Assume doing multiple operations, add, division, multiply. Once the division is exception occurred, then even the program wants to move the next case. How to write and achieve? I think I showed you that earlier. So Shripati, in which case you have to handle the try, except block separately for those methods. In a sense, when you are having division, when you are having, let's say, add, for example, I don't care what we are doing here, but if say it is raising an exception, then probably you can't just put it right here, because in case divide is throwing an exception, you will not be able to get that add called, right? So this is what your concern is. If you see that this is not getting called, and if you really want to give it a call, then it's recommended to do it in this way. So then you can go for an except block and do whatever you want to do there. So probably exception raised. Shivadi, did you get your answer? I think this is the way you should have, you should write the code when you want to handle them separately. Oh, sorry, when you want to call them separately. When you put them in one single try block, you can say that they are now dependent. So if add doesn't raise any exception, then your function add function gets called. So if divide function is raising an exception, add function will never get called. So they are kind of dependent on each other if you put them all in one single try block. If you want them handled separately, you should put them in a separate try block. Shivati, I think you got your answer. Prashant, your question, how to handle an exception generated by incomplete or invalid command execution? Any one command example, invalid command in the sense what? Can you just tell me what exactly the case here you're talking about? So I may get exactly what is your scenario, or what exactly you're thinking here. Vipin, we usually provide a validation. So are they a good, are they a kind of validation handling utilities? You can say so. It's kind of checking whether the things are valid or not. Absolutely. See, even after you do a hell lot of validation, still there are runtime conditions that you cannot avoid, you know. So if you want to handle those scenarios, there you should go for exception handling. Exception handling in a sense, you are trying to see that application is not crashing. That's your main intention. Okay, that's the reason why we are doing it. And yes, you can say that this is a kind of extension to your validation checking. Okay. Ask command. Prashant, what do you mean by ask command? By the way, again, you want to execute the ask command there? If you want to handle an ask command, there is a different way. First, just wait for some time, because maybe today or tomorrow we'll see something called as a modules and packages, and then we'll start using an ask module where we can execute a system command, and there we'll see what happens and how we can handle that. It's not an exception actually, but that's an error. We'll see that, how to handle that. Okay, no problem. Sure, we'll see that. For your question, next line after divide, why are not print? Why are not print? In which case? In this case, it will not print because I got an exception. Did you see something? When I say divide equals to divide 10 and 0, that simply means I pass the n2 as a 0. And because n2 as 0, it has already raised an exception of 0 division error. It already has raised an exception. So after this line number 11, it already has jumped to line number 14. That's the reason you see this line not getting caught. That's what the problem is, in fact. If you want some code that to be executed irrespective of there is any exception or not, you should move them inside the finally block. Okay, good. Shivati, you mean that there are 1,000 business rules? Do you mean that I should write the 100 try-catch blocks? It all depends on you. How can I say that? But in that case, yes, you should, because anyways you don't want to let your application crash, right? And of course, when you're writing 100 try-catch, in that case, that simply means there is something wrong in the logic. Of course, I'm not saying that you should go for writing 100 try-catch block, but I'm saying you should look at the way we are writing the code. A writing try-catch block is nothing wrong, rather it is recommended. But having too many try-catch block is also a problem, in which case there is something wrong with the code, or there is something maybe a problem with the style you are writing the code. Is there any alternative way? Yes, you should refactor the code accordingly, you know. So if you are writing a code, in that case, we given a comma anywhere by mistake only. That is not the error you should be handling. Okay, so probably when you are doing something like this, let's say you are maybe you are doing something like this, or you are maybe having some errors. Those errors are not handled by try-catch error. Try-catch errors will be try-except blocks will be handled by using or rather they are going to handle only the runtime cases. Runtime in a sense, if you are missing something in your code, or if your code syntax is not correct, those kind of errors cannot be handled by using try-catch. Those are syntactical errors. Syntactical errors will never be handled by try-catch. Try-catch is going to handle only the runtime exceptions. Okay, so if you are having hundreds of try-catch blocks, that simply means there is something wrong with the logic we are implementing. And if we are having a logic error or logic kind of refactoring technique, you can fix it, or you can fix that problem. What I'm suggesting here is just look at the code and try to refactor in a better way. So that's the only suggestion I have right now. Okay, having 100 try-catch block is not a big deal. It's not a kind of odd situation, because when you're writing 1,000 lines of code, or maybe you can write maybe hundreds of files in your application, then it's expected to have maybe 1,000 such try-catch blocks. But it's not like you should have a try-catch block in every single function, which is something odd. So if you have to judge here, like which function may raise an exception and which is not going to raise an exception, in which case I can say there is no point putting that add in a try-catch, because I know add is not going to throw an exception at all. It makes sense to go for adding a try-catch for divide, because yeah, divide we are performing an operation here, and n2 might be 0. In that case, exception can be raised. I hope you can understand there. So when you are writing the code like this, probably you have to judge in which scenario you may receive an exception, or in which scenario we may not receive an exception. If you see the exception may not be received, may not be raised, just keep putting that in try-catch. Okay. Within your question, I think the ID takes care of them. It's not the ID. I mean, in this case, it's an ID, but actually the syntactical error will not allow you to even compile your application. Do you see that? If I miss closing curly bracket, if I try to run this, it is telling me that's a syntax error. This is not an error that you can handle. You cannot put this in try catch. You see, already the code is in try catch, but it's not handling it. It's not handling it because it's a syntax error. When you are having a syntax error, there is no way you can handle it by using try catch. And unless it is unless you move or unless you remove that syntax error, it will not even allow you to run your code. Okay, so yes, Vipin, that's it in this case. Okay, so guys, I think you are getting the point here that we are having a try, we are having an accept, and we are having a finally. Okay, so finally is the code which is going to execute in any case, even though there is any exception or even though there is no exception. In both the cases, it is going to execute. Now, probably when you talk about line number 12 here, some people are a little bit confused, like why it is not executing. Why didn't you see that here? I mean, if I run that code again, why didn't you see this here? You didn't see that here simply because this code was never executed, because I got an exception here in divide. Because of the exception, it already has jumped on line number 14 and it tried executing that code there. Okay, so when will get that when will get this line executed? So probably you know that this line will get executed only when there is no exception. Let me run this code. You see, this code is going to get executed right after this function, right after you are kind of getting a valid result of division. My God. Okay. Okay, so now what I'm trying to say here is there are two situations here. I hope you can understand that. There are two situations, like when you are having an exception, these statements will get executed. When there is no exception, this statement will get executed. And when there is exception or when there is no exception, finally block will still get executed. Again, everything is good. There is no problem. Everything is working as per expectation. But just to make sense of it, you can say, put this in a kind of an else block. Now, when you say else block, again, the else block should be after something like an except block. So what do you mean by this? This means we'll try to execute this. If there is an exception, those exceptions will be handled by except block. If there is no exception, will be handled by else block. And if there is an exception or if there is no exception, finally block will get called anytime or every time. I think next line after divide, maybe I'll say else block. So you will understand what am I writing here. So you see that the else block is going to get executed only when there is no exception. See, I passed 5, which means it is non-zero. And because it's a non-zero, it is going to give me a valid division answer here. That's 2.0. That means there is a no exception. And probably you see that else block is called. Now, if I pass 0, you know that this is going to raise an exception. And because it is going to raise an exception, it simply jumps from here to line number 13. And from here, it directly goes to the finally block. This is a kind of convention to follow. There is nothing wrong. There is nothing wrong even if you put this line here. It's nothing wrong. In other languages, we generally do it in this way. But Python says, make your code little bit readable. Anyone reading this code will easily understand these are the situations or these are the statements will get executed only when there is exception. This code or maybe this block will get executed only when there is no exception, and this block will execute in any condition. Whether there is an exception or whether there is no exception, this block will always get executed. So that's the way it generally does the job. I hope you are getting it. Parag, any specific use of finally block? Many actually. If you're opening a file and if something goes bad within or while reading the file or while doing something, then you should always close it. So put that code in finally block. Later on, when we start consuming the REST APIs by using Flask, we'll talk about that later. We'll create some Flask web services and we'll try to consume them in our application. In which case, we'll open an internet connection, and while doing something wrong, if an exception being raised, I should always close it. So closing connection is required in any condition, whether there is an exception or whether there is no exception. Closing connection is a kind of required stuff. Put that code in finally. So there are many situations where you want to execute a piece of code. If there is exception or if there is no exception, you should always move that block of code in finally block. Okay. That answers your question. Preeti, your question, what could be the actual use of else when we could use the finally? Preeti, you are slightly mistaken here. Finally block and else block, both of them are working differently. Finally block will get called in any ways or in any condition, irrespective of any exception. Even if there is an exception or even if there is no exception, still finally block will get called. Else block, on the other hand, will get called only when there is no exception. So only when there is no exception, finally block will be called. Only when there is exception, except blocks will get called. And when there is an exception, on where there is no exception, finally block will always get called. Okay, you cannot compare except, else and finally. Except when there is an exception, else when there is no exception, and finally it will get called every time, anytime, every time. So basically, whenever there is an exception or whenever there is no exception, still finally block will get called, but else will get called where is no exception. Except block will get called when there is an exception, and that's how it does the job. I hope you are getting it. Okay, good. Guys, have you understood this? This is called as an exception handling. And exception handling, you have seen try, except, else, finally, and raise. There are 5 keywords we have used here. Those 5 keywords signifies different things. Try is a block, except is a block, else is a block, finally is a block, while raise is the way you are going to raise a new exception. We already have seen what blocks, what these blocks are meant for, and how can you write the code in those blocks, and what type of code you can write in this block. Okay, so being said that, I hope you know how to handle an exception, how to write that try, except block and stuff like that. Now let us continue further and take a real look at what can be a real life example of exception handling. I gave you a couple of them earlier, but this is a little bit different. I want your full concentration. This is little bit different. We are going to reveal some secrets here, so please pay attention. So if you can understand that, you can understand the next point as well. Pretty simple, but I want you to pay full attention, because if you miss something, you might not understand the concept, or you might not be able to write the code. So try to see this. I have a function 1 here. Doesn't matter whether there is any function or not, but good thing is I can comment it by using that function call itself. So I'm going to write that in a function. Maybe I'm going to have a list here, list of 10, 20, 30, 40, 50, whatever, that's okay. So this is nothing but a list of numbers, I want you to tell me, how can I run a for loop here? How can I run for loop, and how can I get all the numbers here? Is there any way you can tell me to run a for loop very quickly? Yes, there are 2 ways. One is you can go for traditional, and the other one is you can go for each. Okay, so let's take a shortcut and say for number in numbers, and probably number so, and probably in this case I'm just going to print the number. So print number. Okay, so this is going to be my function 1, and probably things are looking great. So here it is. This is a for loop, and that really works. Now my question here is how it works. I don't understand how that for loop knows where to start, where to end, and when to end. Because I see that there are 5 numbers. If I know, if I want to do it myself, that I know that I should start from 0. I should end for, let's say, last value is like 4, somewhere there, and I need to stop my iteration there. If I am managing my own index values, I can do it in that way. But the question here is how for is doing it, So how for is doing it? What do you think? Is for maintaining the index values internally? No, it's not. Why it's not? Because of a concept called as iterator. Now, please understand, there are 3 ers in Python. There are 3 ers in a sense. 1 er we already have seen, decorator, if you can recall. This is iterator, and the next one is something called as a generator. So the decorator, iterator, and generator. So these are 3 ers in Python. And these are 3 famous ones. All of them are pretty much useful in different scenarios. Decorator, we already have seen that last time in depth, I hope, and you still can recall. At the rate something can be considered here as a kind of a decorator. Now let us understand what an iterator is. Okay. To do this, let me show you what happens behind the scene and what for loop does. I mean, what for loop is kind of writing the code internally. To understand how for loop works, first let me call an iterator function. Iterator in the sense iter function. The iter function on numbers would give me something called as iterator object. This iterator object I'm going to use to get the next value from the iterator. Let us not do anything. Let us first print what exactly that iterator object means. So probably if I just run, it tells me that it is a list iterator object which is loaded at this memory location. I don't get any information out of it other than just memory address. It's okay. Iterator, decorator, iterator, and generator. Pretty. Okay. So this is iterator. Decorator we already have seen. This is iterator in that case. What is iterator? Iterator is the one which is going to iterate over an iterable object. To be precise, I'm going to put one more word here. I'm not going to say now. I'm going to say iterable. And then I'll say iterator. What is iterable? Iterable is an object that can be iterated. As simple as that. Iterator is the one who iterates. Who iterates. That's it. So in this case, maybe I can say, looking at this example, the list is iterable. So maybe I can say list object is iterable. What do you mean by that? List object is iterable means we can iterate over list. While who is iterator? Iterator is the one who iterates. Now who's the iterator? Now list provides an iterator called as list iterator, is an iterator which iterates over that list object and gives you all the values you are looking for. So for loop internally uses this iterator. How does it do that? Let's see. How does for loop takes care of getting that iterator and gets the value and probably shows that value to you. See this. So now it is crystal clear that this is a list iterator object which is given by list, because numbers is a list. That's the reason why I'm getting a list iterator object. And now I want to get all the values. To get all the values, you have to call a function called as a next and pass an iterator there. So this iterator, which we have received by calling an iter function, will be able to iterate over that collection and will be able to give me the next value. How does it give the next value? I don't care. It is supposed to give me the next value. That's it. Let us see what does it print. If I run my code, you see it is printing the next value as a 10. Okay. Let me try printing next value again. See, I'm printing next once here on line number 18 and next another time on line number 19. When I say run, you see 10, that's the first object or the first value that's giving me by calling this next function. And the second time I call next, I got the second value. Third time I call it, probably I can see I'll get the third value. Fourth time I call it, I'll get the fourth value. And fifth time I call it, I'll get the fifth value. And you see here, it's 10, 20, 30, 40, 50. Behind the scene, Python, the for loop does this. For loop gets an iterator on your object, the one which is iterable. And that iterator, it is passing it to another function called as next. The next function goes inside that iterator and gets the next value and then puts that on console. I mean, it not next puts the value on the console, print puts the value on console by getting the value from next. Now the question here is, what if, I know there are 5 values, but what if I put this statement one more time? What is going to happen? See, the moment I run my code, my application crashes. You see that? It's exit code 1 means application crashed. And what am I getting here? Oh, it seems like it is telling me that one exception has been recorded, and that is called as a stop iteration. This is an exception. Okay, do you get something? So probably whenever I get a stop iteration, it's an indication that I should stop. Watch what happens now. I know how to handle this scenario. So I'm going to go back and say try and say whenever I get an exception, which exception? Stop iteration exception. I should say end of the list. As simple as that. Let me go and say run, and you see that I'm just able to get only first 5 numbers, and it says that end of the list. It's not crashing anymore. Not only 5, but if I add maybe 10 different times, you see it's just going to print only first 5 because there are only 5 numbers in my numbers collection, and then it generally stops. And of course, this is what is expected, end of the list. That's it. So internally, the for loop calls this iter function on that object, which is iterable, and then it tries calling the next function till it receives an exception, stop iteration. This is how for loop works behind the scene. Oh, really? Yes, this is how the for loop works behind the scene. This is generally the condition that can be handled by for loop by looking at the stop iteration exception. Why am I telling you this? I'm telling you this because I want you to see that stop iteration is an exception, and this is how we are handling it. And just now we have finished the topic of exception handling. So how the for loop is doing the job, you can see it here, and maybe you can get some hint. Think about the scenario. Now, this is a real iterator I'm going to write, okay? So please pay attention. This is a little bit different than what we have seen. This is where list object or list function is called, or maybe the list object is what we were getting. And that's the reason why we were not bothered about getting the iterator. But now, probably I'm going to go back and create my own implementation where I will create my own iterator and will try to solve the job, okay? Let's see what does it do. By the way, before I go to the example, can you please confirm whether have you got the concept here? How does that for loop work? Have you understood that? Very good. So for loop works by calling iter function first to get an iterator, and calls that next function. Okay, calls that next function till it receives an exception, stop iteration. That's how it works. Okay. So now let us go back here and get one situation or scenario or whatever, a simple real life example, you see. Okay, so say maybe I have a class. I'm going to make it very simple, by the way. Let's make a class like say employee. You can go for person, employee, and all of this inheritance hierarchy chain we already have seen earlier. It's okay, not important at this moment. So I'm going to say def init. I'm just going to say that employee name and employee ID. It's more than sufficient to start with. I'm going to say again dot name equals to, underscore name is equals to name, and self dot underscore employee ID is equals to employee ID. That's it. So now we are having a kind of an employee representation here. I'm going to override this str, and probably you know how we can change this into a print function now. So probably I can say something like an employee, which is having a name, that's self dot underscore name. Better we first print the ID, which is in this context self underscore employee ID. That's it. So this is what I want to go and create an employee object for. Excuse me. I'll say employee. This is the first name actually. So I'll say employee 1 and the ID 1. You know, so I'm just going to go back here, and no, I can't do it now. I have to say employee or directly even. That's it. When I say run, probably you can see an employee object on console. Simple, as simple as this. This is an employee ID 1 and employee 1. As simple as this. Okay. Forum, that's a documentation you should look for. So basically, if you look at documentation, you will see all these exception given by Python. Okay. Now, what I'm trying to say here is it's not one employee. Actually, I'm going to create one separate class. This is going to be a company class, for example. So probably I'll say this is the company having a name and address, for example. Watch what I'm trying to do here. And probably I'll say self dot underscore name is equals to name, and self dot underscore address is equals to an address. Okay. Other than that, I'm going to create a new list for keeping my employees in. So probably I'll just go back here and say a list of employees. To start with, this is an empty list. Okay, we'll see how do I get the employees and how do I put them here. But right now, what I'm going to do here is I'll create a definition and say print info of that company, where I'm going to say print, maybe I'll put this as 80. And in between this, I'll say this is the name of that company, self underscore name. And because this is a list of employees, I want to just print all of them one by one by using a for loop. So for employee in self dot underscore employees, and there we can say print employee. I hope you can understand that when we are printing the information about the company, we are printing the company's name, and then we are printing all the employees company is having. So probably I'll just mention that this is an employee list. Okay, so this is how we are kind of doing the job, as simple as this. Okay, so when you talk about this scenario, a company is going to have an empty list to start with. So even if I print that, nothing is going to get printed because it's an empty list. Think about this. I want to have a facility to add a new employee into the company's object. In a sense, there should be a functionality where an employee can join a company. In which case, I'm going to go back here and say add employee, or employee is going to join here. So probably this is the name of that employee, and probably this is an ID of that employee. Right now, I'll pass ID explicitly. Otherwise, I can generate that ID automatically as well. It's okay. Now what I'm going to do here is self underscore employees dot append, and here I'm going to create an employee class object and put that name and ID. Do you understand what am I writing here? I'm giving you a chance to add an employee object here right inside this, so that I can keep multiple employees inside a company class object. So that simply means we are having a kind of one-to-many relationship. One is, one company can have multiple employees. This is the scenario I'm implementing here. Let's see in real, how does it work? Can I just go back here and do it? We can. Let's see this. This is a company which is having, let's say, company name, company one. Let's say address is Pune, for example. And then we can keep on adding as many employees as we want. So this is an employee, let's say employee one, and ID is equals to 1. Let's come back here, add a couple of them, say employee 2, 3, 4, and ID 2, 3, and 4. That's it. And then we can say print info. When I say print info, you would expect the company's information and the list of companies list of employees like this. Everything works fine. Now, probably what I'm thinking here is like, because I know that this is a company and company is going to have list of employees, isn't there any way I can run a for loop on that company and then I can get all the employees one by one, like what I did last time? If you can recall the last example, I kept numbers in a list and then I tried to go get all the numbers by using for loop like this. Right? So this is what we already have done many a times earlier as well. I want to do something similar here. Here I can do it because I know numbers is a collection of, numbers here is a collection of integers. For example, I know C1, that's a company, is a collection of employees, because I know there are many employees in the C1. So if I want that to be done, like for employee in C1, and then if I want to print that employee, will it be possible for me to do it? That is the question. This is what I want to achieve. Let us see if we can. If I say run, oh, it's not working. It's not working because it gives me an error and says company object is not, read what it says, is not iterable. What is iterable? Let's look at the last example. We already have mentioned this. Iterable is the one which can be iterated. Okay, so that simply means basically whenever we are talking about something called as an object being an iterable, that has to be iterable. It has to be iterated. But how do I declare myself that I can be iterated? Or how can I say that C1 is kind of iterable, or it can be iterated? How do I do this? To understand that, we'll have to first dive into details of what for does behind the scene. I hope you still recall a minute before I said that for internally works by calling an iter function on your object, and it gets an iterator. So iterator is what for loop gets, and then it keeps on calling the next function. So next iterator, this is what it does, iterator. In this case, I want to go back and say, do I have any iterator object here? So print iterator, print iterator. If I say run, you see that company object is not iterable. That's what it is kept on trying. It's kept on saying me, because when it calls a iter function internally, it cannot get anything out of C1. Why it is not able to get anything out of C1? Because iter function internally calls C1. So this is how the statement will get transformed to C1 underscore underscore iter underscore underscore function. I hope you can understand that now, like what we have seen yesterday, method overriding, operator overloading. It's the same concept, it's an extension to it. So probably if I want my object to be iterable or my class to be iterable, all I have to do here is this method, get it overridden and return an object. So what am I going to do now? I'm going to go back here and I'll implement this underscore underscore iter, and I'll say return self. Self means return the same object. Let us first get it iterable, and then we'll see how we can iterate over it. So when I say run, probably now I'm still getting an exception, but you see the message is changed. Last time it was complaining like, yeah, it is not an iterable, but now it seems like it is telling me something else, but still it's not giving me that idea, not giving me that error which I was getting earlier. Remember last time I was getting an error saying, hey, this is not iterable. Now it is iterable, but it seems like it is giving me an error saying iter returned a non-iterator of company, non-iterator type company. Means when I say I am iterator, I'm iterator of my class, then I should have a kind of a proof. What proof you need? The proof you need here, because right next to this iterator, I'm supposed to call that next function. Let me tell you what happens here when you call next. When you say next, it is going to call it like this way, iterator dot underscore underscore next underscore underscore. I hope you are getting the point here. So whenever you are going to call the next function internally will call another method underscore underscore next underscore underscore on the iterator. Watch what we are returning here. When I say iter, from this method we have returned self. Self means it is nothing but C1. So why it is not working right now? It's just because when we are calling next function or next method on C1, it's not working. It's not giving me anything because the next method is not available. That's the reason why it is not working. If I come back here and say underscore underscore next underscore underscore, and if I return something, the object which I want to return, for example, I want to return next of employee, self of employees of 0. See what happens now. When I say run, my program would work without having any problem, and I got my first employee object. If I call that next couple of times, and if I say run, you see that every time I'm getting my employee 1. What is happening behind the scene? I'll tell you here. Look, let's look at this. When you call that iter C1, it calls this method and it returns the self. When it gets the self, when it gets an iterator object, which is nothing but a company object for me, it simply calls the next method underscore underscore next underscore underscore, which is this, which returns an employee object 0, which is printing here. Again, it is calling next iterator, means again it is giving me the self underscore employees 0th object. Again, it is printing it here. Same thing happens over and over and over. That's the reason why I'm getting the same object every single time. Now, the only problem here is I am getting the same object. Actually, it should have given me the next object next time when I call it. So basically, I should keep track of my index value. Like I should not go for a hard-coded 0th index here. So probably what I'm going to do here is I'm going to come back and say self underscore underscore index. Maybe we can say index is equals to 0. So this is where we are going to keep track of index, which I should reset when someone asks me to give me the iterator. So someone gives me iterator, I'll start from 0. I hope you can see that whenever you run a for loop always starts from 0 because it calls that, or it sets that index 0 in this method iter. Now, all we have to do here is instead of returning, this employees of 0, I should say employees of index. That's it. And of course, when I do it, it's better we can just save that, save that employee somewhere and then get our index incremented to the next value. Do you understand what we are doing here? So probably here we are going to return an employee object. So instead of giving the entire control to someone, we will run the for loop, we will maintain that index internally. So if I say run, look, last time I was getting first all the time. Now I'm getting first, second, and third. I think we are having 4 employees. So there is one more chance that I can get, or I can take here and try to see whether I can get the 4th employee. Yes, I am. And if I call it the 5th time, it is now going to crash. You see, it is going to crash because it says index error. I don't know whether you are getting it or not, but last time I told you something like when for loop stops. For loop stops when it receives an error or when it receives an exception of stop iteration. So the only thing which I should do here is whenever I know the index is going kind of beyond the number of employees, I should raise an exception. Otherwise, I can continue incrementing that value, which means I'm going to go back here. I'll say self underscore underscore index, which is less than len, the value, or maybe the length of self underscore underscore employees. If it is less than employees length, then return, then get the value and return the employee. Otherwise, how do I raise an exception? I'll say raise a stop iteration. So if the length is less than number of employees, go ahead and do it in this way. If there is no employee left, if you already have gone to the end of that list, employees list, just raise an exception, stop iteration. Now when I say run, you see application is still still crashing, but this is the valid crash. Stop iteration is the valid crash. If we can write the same piece of code what we have written earlier, let me just go back and print this couple of times. And you know that if you are doing it in this way, it should be always in a try catch and except and say print like last time end of company list or company employee list. And when I say run, probably you see my application is not crashing. My application is behaving as per expectation. If it behaves like this, guess what? Now you can write this piece of code for employee in C1 and boom, you see my employees can be iterated directly without bothering about calling that function separately. I don't need that iterator. I don't need that printing the iterator now. I just need to see whether the for loop really works here and see the for loop not only working, but also it is giving me the valid employees. Imagine a scenario that you are having a bunch of employees in company, and if you want to get all the employees, instead of going for print or function like print info what we have done earlier, this is way simple. Just run a for loop in company and you will get an employees object. Maybe the same thing can be implemented for student and school, the same thing implemented for teams and players, n number of scenarios. So probably what we can do here is, it's simply you have to check whether the index is going beyond the employees collections limit. If it is, then raise an exception, stop iteration. And then otherwise, I mean, if it is not, or if it is below the length of employees, then return the next value. Shreya, can we do index plus plus? To be precise, we should not. And that is a kind of discouraged, not only in Python, in all the programming language. If you're using index plus plus anywhere, stop doing it. It unnecessarily hurts your performance. That's the reason why I'm writing the code like this. Self.__index plus equals to 1. So that's the right way to implement it. Few languages like Swift, they know they know the issues with this plus plus, and that's the reason they will not even allow you to write that code. So there you will not find the plus plus operator because it's not recommended because of the performance reason. You know, so the better option is to go here and say self.__index plus equals to 1. That simply means you are incrementing index by 1. What if we want only the list of employees? That's what we have done. Didn't you see here? We got the list of employees here. See, that's what we are doing here. So we are getting the list of employees here, one by one. Okay. __iter return self. Please explain it once. __. Okay, you are talking about this one here. Iter returns that object on which you want to implement the next. So I have implemented next inside the self class or inside the same class, and that's the reason why I'm returning self. So probably Praneeth, that self simply means which class is implementing next. The same class is implementing next. That's why we are saying self. Okay. So self, the iter needs to return the object which is going to iterate over it. Who is iterating? I think the next function is iterating, and the next function is available in the same class. That's the reason why we are saying self there. Okay. Vipin, need a quick recap of getting the employees. No problem. So what is happening here is this: when you are running a for loop, behind the scene, it is calling the iter function to get the iterator. Iter function internally calls the dunder iter, which returns the self object, which means we are getting the C1 object again. And on top of this, it keeps on calling the next function till it receives an error, till it receives an exception, something like a stop iteration. So that is what is happening behind the scene. In order to implement it, we have implemented two different methods. One is called as iter and the other one is called as next. Both of them are dunder methods. So dunder iter is going to return that object which is going to make your class iterable, and dunder next method is going to return the next object at the next index value. The index has to be implemented, or index has to be managed internally. That's what we are doing here. So probably we are taking care of index. If it is less than number of employees, then we are returning the next employee. If it is not, then we are raising and stop iteration. I would just ask you to pay attention to this one more time. I know it's a little bit difficult. I told you there are 3 Rs. All of them are difficult to understand. I gave you an example here. So sit on this, maybe take a breath a couple of times and then try to read the program. You would understand. I know it takes a little bit time to digest this code, but once you understand, you can use it in n number of places. This is the simplest example I'm just showing you. Okay, what if I want to get only the last employees? No, I hope you remember I mentioned this earlier as well. When you are using the for each always starts from 0. It always go to the end of the list. Same thing is happening here as well. You cannot just go and get the last employee. If you want, then you will have to write a separate method to return the last employee, or to return the employee list explicitly. Okay. So Prashant, this is not the example where you are just going a specific employee. This is an example where you are going for all the employees, like what you were doing earlier when you were having the array of values. You know, you were running a for loop there. So when you say for loop, it always will start from 0. It always will start from 0, and it always will go to the end of the list. Excuse me. Rohit, it looks like we are iterating over company and getting the employees. Absolutely. Not making sense. And I did not understand correctly. No, it's absolutely right. We are iterating over company because we want to get the number of employees. Rohit, answer my question quickly. When you are iterating over numbers, let's say you are running a for loop here, what are you getting? When you are iterating over list, what are you getting? Number, absolutely, because your list is made up of numbers. Think about a company. What is company made up of? Employees. What's the most important thing in the company? Employee. That's a different story. Company doesn't believe it, but still, employee is the employee is the one because of which the company exists, isn't it? So it should be, no, I should not, you should not get the company. You should get the one which is making the company. If you think about this scenario, list and a number, if you are iterating over list, are you getting list out of it? No, you are getting the value inside it. What is the value inside a list? It's number. What is the value inside the company? It's an employee. So when you iterate over company, you would get an employee. When you iterate over list, you get a number. Okay, this is conceptual implementation. How you want to implement it, it's up to you. I can think of a company is a collection of employees. A school is a collection of students. Maybe a team is a collection of players. Getting my point? So whenever you think about a collection, it's not like the collection is made up of collection. Collection is made up of some individual values. And if I want those individual values, this is the way to do it. I hope it will take some time for you to digest it, but I hope if you sit quietly and if you think about this one more time, you would agree with me that whenever you're thinking about a list, you will not get the list out of it. You will get the values out of it, the values which you will find inside the list. Preeti, I have given a more next statement. It is repeating the print like 1, 2, 3, 1, 2, 3, 4 instead of ending it after the fourth one. There is some problem with this logic then. You're not resetting it properly or you're not writing this properly. Please pay attention to this one. If it is not stopping, that means the stop iteration is not working properly. Okay, so stop iteration has to be raised when you have reached the end of the list. If it is not, then you will get the result like this. Okay, so probably you're resetting it somewhere. That's the reason why it is not working. Shripati, consolidate the report purpose using this method. Yes, the consolidation is simply, I want to get all the objects which are making up my bigger object. My bigger object is company. My smaller object, which is making up my bigger object, is an employee. So I want to get all employees in C1, all employees in company. I would do that. Guys, don't look at this an example of companies and employee. Look at this example of how we can get the iterator in picture, how a for loop runs behind a scene. For loop runs behind a scene because for loop is doing exactly same thing on the list, and list is already implementing the iter and the next method. So that's how the for loop works. Okay, in real life, if you see a collection which is having different numbers in it, then you can implement something like this. It's very rare that people generally use this kind of advanced feature there, but knowing those things will give you a kind of advantage. So that's the reason I'm telling you this. To be very precise, you don't need to know those 3 R's. 3 R's is nothing but a decorator, iterator, and generator. But it's okay to know them because these are kind of concepts you might encounter maybe somewhere in the future. Okay. Most of the times we generally use them. I'm showing you how to create them. Okay. So Preeti, your question, may I look at the code? Okay, no problem, sure. Lomash, your question, can we say that it is an internal for loop implementation of object of class? Absolutely. This is the kind of replacement of running this loop or maybe writing this function here. So instead of you doing it here, let others to do it on behalf of you. That's what we are doing here. Okay. For get it here, return self-employees gives the same output. Yeah, of course. For any given problem, there are multiple solutions, Ketan. I hope you are getting, you can recall that dialogue. So for any given problem, there are multiple solutions. This is one of them. I especially was talking about this example because it uses an exception. I wanted to show 2 things here. How you can use that stop iteration, one, and second, how you can make your class iterable so that you can use it inside the for loop. This is the first time we have used our object inside the for loop. This wasn't done before, and I could not do that before because I wasn't known to this functionality called as iterable. I couldn't talk about this functionality because we didn't know what exception was and how to handle that. Today we have seen it. Maybe we fit in that particular chain that we saw exception, then we saw stop iteration, then we came to know that if I implement it in this way, I could put that in my for loop. Everything went in a kind of a flow, and that's the reason I showed you. Sometimes I regret showing some things, but anyways, Now it's already been shown, it's already been recorded. So if you find some trouble understanding this at this time, probably I would say spend some time, spend some enough time on it, you will understand that, you know. Anyways, it means like people generally do not get these concepts. I should not show them, but anyways, it happens, you know, it's in a flow, and I try to show it. Now that simply means there is no point of talking about generator, because generator is an advanced iterator. So whatever we have done today explicitly, if you want to do it without object-oriented programming, then generator will help you to do that. So generator is an advanced iterator. It's better not to talk about it. It's better you can just digest it. If it is okay, well and good. If it is not, just skip it. Not a big deal. Okay. I think 50% people already have dropped when I started talking about this concept. Remaining 50%, those who are here, probably they can at least get an idea about what the iterator is and what the iterator can do for you. Anyways, it's okay. Even if you don't get it, it's not, you're not going to lose anything here. It's just a bit advanced concept. If you get it, well and good. If you don't get it, just don't be tensed. It's okay. There are few things in life will take some time to digest. It's okay. Okay, it's like it's like you are getting married to a girl. It takes time to understand your wife, but once you start understanding her, probably the things will go smoothly. That's what happens here as well. Oh, it's a real type example. You know, if you're married, then you will understand what I'm talking about. But this is how the life can be a little bit smoother if you want to live it in that way. Anyways, sometimes you can ignore it completely, you know, so you can ignore it, ignore these functionalities talking about, not the wife. You can't ignore wife, you know. So if you can ignore this functionalities, nothing is going to happen. I mean, you can still live your life, but sometimes you will get confused, like, what should I do? Is there any better way? And then you will start digging around. So if you want to live your life happily, just do it. Try to, you know, just map it with your real life. You will understand that. Anyways, leave it. It's too much time right now. It's okay. We'll call it a day. We'll continue tomorrow, and probably we'll have to go for the next example or the next point. That's packages and modules. You know, so tomorrow we'll start talking about the modules. Tomorrow we'll start talking about the packages, and tomorrow's the first package, or tomorrow's first module we are going to talk about is an operating system. Okay, so we'll see what exactly we can do there. Again, thanks a lot for attending today's session. As usual, I appreciate your patience. I hope I'll see you tomorrow exactly at 8 o'clock. Till then, bye-bye. Have a very good day. See you.